Good afternoon, guys. Welcome to the Advanced Refrigeration Podcast, continued training on the E2 controller. Today we're going to be going over analog sensor controls and how to program them and how to set them up and what they can be used for. So today we're going to start out, like always, in terminal mode. We're going to log in the controller. Okay, we are going to hit the menu button. Since we're going to be adding a new application, we're going to go down to 6, Add Application. We are going to look up and we are going to go over an analog sensor control. So we're going to add one. It's going to ask if you wish to add it. You're going to say yes. Okay, couple things first. Make sure you're in full mode. If you're not in full mode, always check us on E2, hit ALT and F, and it'll put it in full mode. Okay, so first things first, we're going to make this analog sensor control. So we're going to name it. So we're going to call this superheat. We'll make a couple of these, and I'll show you guys how to do them. So long name, you can name it whatever it is. You can put some information about it. Number of inputs. So you could have up to 4 inputs in analog sensor control. So some you just need 1 if you're doing a cut in, cut out. A simple cut in, cut out. If you're doing some math, you need 2. So we're going to have 2. So engineering units. So if you hit F4 look up, this is what it's going to be if it's degrees Fahrenheit, Delta degrees Fahrenheit, Celsius, inches of water column, PSI, bar, KPA, RH, feet per minute, like MPH, whatever, GPM, whatever your engineering units for whatever you're trying to control is what you need to assign here. So we are degrees Fahrenheit, so we're going to go ahead and just exit out of that. Okay, combination method. So this is where your math comes in. So you're going to hit look up. Okay, you have average. So if you want to average 2 sensors together, this is where you would use average. So if you have 4 sensors and you wanted the average of the 4 to be the control value, you use average. If you wanted it to be minimum, you could use minimum, maximum for maximum. First, don't ever use really. A mix would be average of like the first 2, I think. So down here, then you have addition, subtraction, multiplication. So input 1 plus input 2 divided by input 3. So input 1 and 2 first, and then input 3. There are a multitude of things you could do in here. Square roots, absolutes. Generally, what I use is average, and then input 1 minus input 2, or input 3 minus input addition and subtraction. So we're going to use subtraction. Okay. Now this show advanced, you're not going to have a lot of options if you do this. Some things you need a lot of options, some things you don't. So you could have an alternative combination method of average. Say if something happens, you could have an alternative combination method. Combo low limit, combo high limit. Generally don't use these. Disable filter, so you could enable the filter and you could filter your inputs. Emergency command out if it's commanded to be an emergency. So your update rate, I generally change these. So you could go from up to a minute. I bring mine down to 2 seconds usually. So again, this is an older E2, so you got to type the whole thing, 00 dot semicolon 00 dot semicolon 02. You want a faster update rate for certain things you don't need it on. Okay, now is your inputs. So if you hit F4, hit lookup, you could choose your board. Lookup shows the board. So we're going to do superheat. So next tab, Oops. Okay, now we're going to get our saturation from our suction group. So we could do a conversion cell and get it that way, which we'll do a couple quick videos on that, but I'm going to show you guys how to use this the actual suction group saturation. So if you hit F3 edit, go to alternative IO formats, go to 2, which is area control property. So now we're going to hit lookup. We're going to choose the E2. We're going to go to an application. We're going to hit lookup. We're going to choose the suction group. And I hit it one too many times, so let it do its thing while it freaks out for a minute. Now it's going to freak out the other way. So rack A enhanced suction, and then under outputs, you can hit lookup. So you have the ability to use current superheat. We'll go over that in a minute, but I'm just showing you guys. So we're going to choose saturated suction temp. So we're going to subtract saturated suction temp from what would be suction temperature. Okay, then you have control ends. So you have an occupancy. So you could put an occupancy input in here. So occupancy would be whether it's daytime or nighttime. You could use this for alarming. So if you have an occupied alarm or a deoccupied alarm. So like say if during the day you wanted to write an alarm where this is going to alarm during the day only, and at night it's not going to alarm, so you won't be there. You could use this occupancy. Alternative combination. So that alternative combination set point, if you tie that input to something, you could have an alternative combination. You could use that alternative combination. Alarm disable. This would be an input. You could disable the alarm. So you could do that off a time schedule, for example. Like, so say like you wrote this to monitor the floating of the circuit. Say the circuit's not floating or the superheat's too low. You could monitor, you could disable and enable the alarm to only alarm during business hours. So that way you can call a technician out, not on overtime, but on straight time. I mean, this stuff you don't need for everything. This is just basic stuff. So if you hit the next tab. So then you got set points. So you have a cut in and cut out. Okay, so like say our cut in value, we'll say this is controlling a de-superheating valve. So it'll cut in at 50 degrees of superheat and cut out at 30 degrees of superheat. Okay, then you have a cut in delay, a cut out delay. Then you have a cut in unoccupied and a cut out unoccupied. So this could be used for nighttime when the head pressure is lower. If you did some like crazy stuff like this, you could have two different cut in and cut out set points, and the same thing with the delays. Now, if you don't go to show advanced, you're not going to see the all these. You're just going to have the cut in and cut out in the times. So, like I said, a lot of things you don't need this for. Command out is going to be your board output. Command out when on. You could switch this, so you could make it backwards. So you could change this to off, and then this one to on. So when it's commanded off, it's actually on. You could flip the logic of the relay, or the command out relay. So command out is always going to be your board point. Alarm out, depending on if you're using it. And then this is another thing. You could use alarm went on, alarm went off. You could change these. So if you don't want alarms on it, you could change it to none. It's not letting me do it right now. You could change. You could basically square these off if you're on the proper version of Ultrasight. Okay, and then notice, same thing. You could change these, and then control value or cycles tripped. So control value is going to be a logging point. Cycles tripped is going to be a logging point. Cycles tripped is going to be how many times it went on and off, and then cycles is going to be how many times. Same thing. It triggered the on and off. Limiting. So if you go to limiting and you click the question mark arrow, this output will be on whenever the combined input control value is beyond the limits. So that's if you set up the limiting at the very beginning, not something you use a lot. Limited combo, not something I use a lot. Cut in, cut out, that's going to be a control value. Okay, then bypass. This would be a bypass. So you put you could write to this point. So you could make this a area control. So you could make it on or off, or this bypass input. You could also tie it to something. So say if you wanted to bypass this point on if something happens, or like if you wanted to bypass a valve on when this happens, this is what you would use the bypass output for. So the bypass controls, it would automatically override whatever this bypass value is, whatever the output is if it's on or if it's off. When this bypass is called to be on, it's going to override and turn the control value to the opposite. So then in here you have your alarms. So you have your alarm low limit, your alarm high limit, your alarm delay, your alarm clear delay, alarm low limit unoccupied, alarm high limit unoccupied. So you could change two different alarm settings. So you could have a alarm for high superheat when it's unoccupied or deoccupied. You could have a clear delay, same thing. You could have the notice, same thing, notices for unoccupied and deoccupied. Next is your counter. So a lot of people don't use these a lot. I use them for weekly compressor cycles because unfortunately in the E2 they only keep the previous day cycles. So a lot of times I'll do weekly and monthly cycle counts. So I'll use this counter setup for a monthly cycle, and I'll tie the reset count into a sensor control or a flexible combiner that'll reset it. And then every time the compressor cycles on and off, it'll count the times that it's on or it's off. This is good for your compressor cycling. You could do this also with EPR cycling if you want for counting. I do it sometimes with defrost times, like to count the number of times a case went into defrost. If I'm doing like energy commissioning and it's in a spot where like I'm not servicing it, and to make sure the servicing contractor is not changing set points to make sure it's not going into defrost more than once a day or whatever, or it's, we're having like random issues that I need to count how many times something's happening and I can't do it with the E2. This is the way to make sure you can count. So power, KW, I've never used this. You could use this for demand shedding. So if you need to demand shed a load. So if we go through and we hit enter, now this is going to be a sensor control controlling superheat. So we want to save it and go to sensor controls. So digital and analog sensor controls are all under the same thing. So if we go to superheat, I don't have the proper value set up or proper sensor set up in here. I only have a couple sensors on here. So it'd be control value 1 would be your suction temperature. Control value 2 would be your saturation. So that would give you your control value. And then you have a set point, a cut in at 50, a cut out at 30, So your command on. So right now we are in error because we don't have any inputs. So our command out is on. So because it's an error. So if we were to flip that around and make it work like a fixed set point, so it would work fine. Now you could also use this to control the things that analog sensor controls are good for is controlling subcoolers. So if you need to control solenoid valves on a subcooler, so you can make a stage 1, a stage 2, a stage 3, you could use that unoccupied set point for nighttime subcooling. Say if you step it back a little bit to save a little bit of energy. Compressor desuperheating valves, if you're doing that, if you're monitoring discharge temps. So if we were to make one for discharge temp, so if we, to monitor discharge temp or to control discharge temp, so say for sensor controls, we're going to go menu, we're going to add one more. We'll add one for to control discharge temp, alarming for each compressor. So add application, you hit look up, you go to analog sensor control, you make one more. Do you wish to edit? Yes. And we'll call this compressor 1. So you got to get kind of creative with these names because you don't have enough space. And then under the long name, I'll make it compressor 1. Okay, so compressor 1 discharge temp. So engineering units, degrees Fahrenheit, show advanced. We don't need to show advanced with this one. Update rate, 10 seconds is fine for discharge temp. I mean, you don't want to make them all 2 because it'll overload the controller. But certain ones where you want the logging to be right, like superheat, pressure, stuff like that, you want the update rate quicker. So this, we're just going to do alarming with it. So we're going to hit F4 look up. We'll choose a board. We'll put an input in. And then we're going to choose, we'll just choose 12. Okay, I'm going to show you guys how to do the logging real quick on a point. So if you go F3 edit, we haven't been doing this, but we're going to start tying it in. So logging setup. Okay, so this brings up the logging. If you hit look up, we're going to choose the base log. Okay, hit enter, and then hit the back arrow. So see how this got this L next to it now? That is a logged point. If you go to any point and it doesn't have an L next to it, it's not logging. So that becomes a problem. You have to set up logging for each individual point on the controller. It doesn't do it for you. There are ways to do it. You can do the whole controller at the same time. It's kind of finicky. It works, and then sometimes it doesn't work. So a lot of times I'll try to set them up as I'm going. So if you go to the next tab, we have a cut in, cut out. So you say you're using a desuperheating valve, you can make the cut in 220 and the cut out 200. And you can make a cut in delay of 10 seconds. We don't need a cut out delay, so go to the next tab. So you can make a board point your command out. So let me do it on this version. If you don't want the alarm went on and alarm went off, you're going to want those taken out. So I'll show you how to do it on Ultrasight when we actually get in there. It's not letting me on this version. So see how these L's are here? That command out's logged, control values logged. So it's going to log those. Those are automatically set up in the controller. You don't have to set those up. So if you go to the next tab, you could do a bypass, whether you want the bypass input on there. Right now it's on if the bypass input is called for. So if you go to the next tab, you could put your alarms in here. So alarm low limit. We'll go 60 degrees. And we'll do a high limit of 250. And we'll do alarm delay of 0.10. Whoa. So we'll do 1.0 for an hour. So if it's above 250 degrees for an hour, it's going to alarm. So alarm clear delay is 0. So then you have alarm low limit unoccupied, alarm low limit, high limit occupied. So we're not using any of those. We don't need any notices. So that's how you set up a compressor discharge temp. So I generally will put all my sensors inside here. Like if I have each compressor, so compressor 1, compressor 2, compressor 3, so that way I can read the discharge temp. So like if you go into this one and you hit enter, so control value is 98 degrees, 100 degrees. It's actually in the supply of my furnace. So my furnace is kicked on, and you can see my supply air temps getting up to 103. So obviously it's never going to hit 200, but yeah, so it's not going to turn on. But if we change the set point, so we go F5 to set up, we say we change the set point. So we go cut in, we'll go 100, cut out 95. Give it a second, let it update. Takes like 10 seconds. So just turn the command value on. So right there we'd be injecting turning on the liquid injection for the compressor, or the alarm if need be, if we had it set to that. So that's how you would program an analog sensor control to do that. So like I said, you could use these for monitoring. I like to set up a lot of sensors. A lot of the sensors don't actually do anything, but they're monitoring stuff. If you want to do simple cut in, cut outs, an analog sensor control is a way to go, like a temperature cut in, cut out for an exhaust fan or anything like that. That's the way to go. If you want to do an exhaust fan, the best way is to practice. You just add it, and just like we did that compressor. So that'd be an easy way to do an exhaust fan, cut in, cut out, monitoring stuff. It's a lot easier to put monitoring on there. So like my drop leg pressure, I'll put everything on sensor controls, like stuff that's not displayed in the suction group or the condenser. I'll put in there so I can easily graph things out, so I can just scroll through things. So that way I know like stuff that I know a tech wants to see, like discharge pressure, drop leg pressure, condenser subcooling, subcooling on the actual subcooler, receiver level. Another one I'll do is I'll do a long-term receiver level. We'll go over that real quick. So if we go menu and we go to 6, add application, and we choose lookup, choose analog sensor control. So this one will go REC long term. So that's how I usually cool it out. So 1 year graph. So you can leave the update rate as that. So this is going to be a receiver level for a year. Obviously, that's not an option on an E2 normally. So it's whatever your log group is. So generally I make a second log group for this. So we are going to be in percentage. I hate when it does this. You see, you have tons of, there's over 119 different options. So percentage, because we're using a percentage. So our inputs would be a receiver level. So you could do it two ways. You could hit F3 edit, alternative IO formats, and you can go area control. You could hit lookup. Instead of tying the input back into this also, which makes it kind of a pain to look at the input screen. So we could choose our condenser application. So rack A condenser, and then output, hit lookup again. And it is not going to let us do it. But if we do it backwards through the condenser, we could do it. So if we go condenser, and we go to setup, and we go to outputs, and we go to it is not an option in this old one. Wow. So basically, you could network it from the condenser, the refrigerant temp, or refrigerant level out from the condenser. Yeah, the liquid level. You could tie that liquid level input to that new one we made. So if we go back to sensors, this is the only downside of working on an old version Ultrasight. So some of the set points and settings don't match up because this is one of the original versions of Ultrasight. So if we go receiver level long term and set up, so if you put your input, I just tied the variable speed fan out right now, but if you tied that to liquid level out, which is an option, what you do is you come down to your control value where this logging is, and you hit edit, and you go to logging setup. You're going to make a different log group, and it's going to be called 1 year. You hit lookup. So you could change the log group on here. So right now it's set to base log from the factory. You could change that to a different log group. I'm using this KW one for my house, but you could change your base log group. So that would be how you do a receiver level for a year. We're going to break down in future videos like how to do like cut-in, cut-outs for subcoolers and examples of like different ones. But I'm going to show you guys an Ultrasight. Let's run through it like the other videos real quick. So we're on Ultrasight. We're going to go ahead and sync the site up because we did all this on the E2 technically. So if we go down to our analog sensor controls, so we have the compressor, or let's do the superheat one. So if we go to graphical status, this is what it looks like. It's basically like block logic in the background, just how block logic would be written. So, I mean, it's kind of hard to follow on the screen. But if you right click again and go to status, so we get this screen. So this would be everything that's going on in here. Your cut in, your cut out, your set points, your inputs. So we're in fault, not available. So this NA one is because the suction group's not active. Command out, digital, it's on. Control value is 0. Alarm is off. Digital, notice off. Cycles tripped off. Combi value, DF. Cut in, cut out, digital, it's off. Limiting is inactive. So if we right click this again and go to edit application, so same thing. Number of inputs, engineering units. It's just a million times easier to do it on Ultrasight. It's so much faster. So your update rates, your high and lows, your inputs. So with the inputs, you just go to your 3 tabs, obviously, and you could choose whatever inputs you need. So control ins, your occupancy, your combo alarm, emergency override enable, your set points, your cut in, cut out, your delays, your unoccupied, everything's in here. Outputs, cycles tripped. Now, when we do the logging in the E2, you do F3 edit and go to logging setup. On the Ultrasight, you come up here to this wrench. So click it. You're going to click this box that says enable logging. You're going to come down here. You're going to go click your log base, hit apply, hit OK. So now see how it's got this graph next to it? That's the logging setup. So each time you set up a point, like an input or an output, please set up logging, because the guy that comes behind you that tries to troubleshoot this won't have any logging, and it's going to be a royal pain. So your bypass value, whether it's occupied or unoccupied, so right there, see, we can make it not active. It wouldn't let me do it on the E2. So alarm went on, alarm went off. You don't want those active unless you're using them when it's cut in, cut out for an alarm. So you want to make those not active. You could do it by typing none. Usually, it's just not letting you do it right now. So your alarms, your low limits, your high limits, everything's in here. Alarm delays, alarm clear delays, alarm low limit unoccupied, alarm high limit unoccupied. So everything's in here. Your notices, your counter setup. So reset, level, edge, invert edge. Level would be change of state. Edge would be back and forth. So we're going to go over those terms more when we break down the flexible combiner one. The flexible combiner one's going to be a couple different episodes. Power would be your kW bump and everything else. And then input output status like you have. So like everything on an Ultrasight is the exact same. It's just way faster and easier to do it. Last thing I want to show you on here. So you could set up individual alarming and inputs. Please don't do this unless you absolutely have to. Don't set up alarming on individual inputs, because if you're using a third-party application to pull data, it could cause problems with their stuff. So please don't set up alarms on individual inputs. If you're going to do an alarm, do it on, see how it's got this little alarm bell right there? I set that up to be an alarm now. So if you see a little alarm bell next to an input or an output, that is an alarm for that input or output. Like I said, it's better just to do the alarms in the alarm section unless you absolutely have to set up an alarm that way. But, all right, guys, thanks for watching. The next one will be digital sensor controls.